In this lecture, we will be solving first order differential equation, first order first degree differential equation by applying Kutta method. Fourth order, obviously, for problem solving, we use this fourth order method because this is more accurate than the second order one. So here is the rule: y1 equals y0 plus k, where k is a constant, equals 1 by 6 k1 plus 2k2 plus 2k3 plus k4, where k1, k2, k3, k4 takes these values. This is what the first approximation. So similarly, we can get the second, third and all the other approximations. So starting with an example. Compute y of 0.4. Example, compute y 0.4 from the equation dy dx equals x minus y, comma y0 equals 1, taking h equals 0.1 by Kutta method. Correct to 5 decimal places. Correct to 5 decimal places. That one. So we have to compute y of 0.4 and the equation is this one, taking h equals 0.1. So at first, comparing the equation with the standard equation. So by comparing, we can write fxy equals the function x minus y, x0 equals 0, y0 equals 1 and h is given 0.1. So starting for the first approximation. For the first approximation, the formula is y1 equals y0 plus k, where what is k? K is 1 by 6 k1 plus 2k2 plus 2k3 plus, okay, I'm writing it once, k3 plus k4. Now let's get the values of k1, k2, k3, k4, where k1 equals h f0, that means h f of x0 comma y0. h is 0.1 into f of x0 0 y0 1, that is 0.1 into the function is x minus y, that is 0 minus 1. So it will become minus 0.1. This is our k1. Now k2 equals h f of x0 plus h by 2 comma y0 plus k1 by 2. So 0.1 into f of x0 0 plus h by 2, that means 0.1 by 2, comma y0 is 1 plus minus 0.1 by 2, that is y0 was 1 minus 0.1 by 2, that means it will become 0.1 into f of 0.05 comma 0.95, that means 0.1 into x minus y, that is, so ultimately it will become minus 0.09. This is our k2. Now moving to compute k3. K3 is the rule h f of x0 plus h by 2 comma y0 plus k2 by 2, that is 0.1 into f of 0 and this is 0.1 by 2, this is 1 minus 0.09 by 2, that is 0.955. Just applying the rule for fxy, that is minus 0.0905. This is k3. Now k4. The rule is h f of x0 plus h comma y0 plus k3, that is 0.1 into, this will become same, x0 plus h, that is 0.1 comma 1 minus 0.0905. It will become result minus 0.08095. This is our K4. Now we can easily get K. K is 1 by 6 into K1. K1 means minus 0.1 plus 2K2, that is minus 2 into 0.09 plus 2K3, that is minus 2 into 0.0905 plus K4, that is minus 0.08095. So the result is minus 0. That one. This is our first approximation, y1. Okay. Now moving for the approximation y1. Now we want to get the value of y of 0.4. That means what does it mean by y1? Y1 means y of x1, right? X1 is x0 plus h. That means y of 0 plus 0.1. That is y 0.1. That means this is the value of y 0.1. Right? Now we need to find out the value of y 0.4. So the step length is, this is our x1. x1 equals 0.1. If we start adding the step length x1 plus h, it will become 0.1 plus 0.1 equals 0.2. Then x3 will become 0.2 plus 0.1, that is 0.3. x4 will become 0.4. Now we already got this one for y, that is y1. Now we need to find out y2, y3 to get y4. That is, this is our required answer, y of 0.4. So we need to apply this procedure 3 more times to reach at that level. So starting with x1 equals 0.1, this is already given, and y1 is the previous result, that is 0.909675. Then starting with K1 will become, for the next step, h f of, that was x0 y0, it will become x1 y1, that is 0.1 into f of 0.1 x1 means, and y1 is 0.909675, that is minus 0.0809675. That one. This is our case 1. For the next step, second step, moving to K2. The rule will be h f of, that was x0 plus h by 2. So for the second step, it will become x1 plus h by 2, comma y1 plus k1 by 2. So 0.1 into f of x1 means 0.1 plus h by 2, that is 0.1 by 2, comma y1 was the value 0.909675 plus k1 by 2. K1 was negative, so minus 0.0809675 by 2. That one. That is 0.1 into f of 0.15, comma 0.86919112. We need to take few more We are taking 7 up to 7 decimal places because we need to make it correct up to 5 decimal places. So that one. Now the rule is x minus y, that is 0.1 into 0.15 minus that value. So it will become minus 0.0719191. Okay. Next is K3, that was K2. Next K3, the rule will become same. Just instead of x0, y0, we need to put x1, y1 because we are on the second approximation. The rule will become 0.1 into f of 0.15, 0.8737154. K4 will become h f of x1 plus h, y1 plus K3. Putting their value, we are getting this one. Okay, so in that step, y2, that is y of x2, that is y of 0.1 plus h 0.1, that is 0.2. This equals y2 takes the rule, that is y1 plus that k means all the value 1 by 6, k1 plus 2k2 plus 2k3 plus k4. You know all the values for this particular step. Putting it, so it will become 0.837462, that one. So in that step we get y of 0.2, taking the value this one. Now we need to find the value of 0.4. So by applying step length h equals 0.1, in the next step we will get 0.3. Then for the next step we will get the ultimate result 0.4. So we are applying for the third step. Here x2 is equals to 0.2 and y2 equals that value. Apply the same thing. K1 equals h f of x2 y2. Right, we are on the third step, so just change that formula to x0 y0 to x2 y2. You can get the value. Then K2 will become the same thing, x2 plus h by 2, y2 plus k1 by 2. Similarly K3, K4 will get the result. Ultimately by putting all these value, you will get y3, that is y of 0.3. It will take the value 0.781637. Okay, then we need to apply next step, fourth step, that is here x3 will become 0.3 and y3 takes that value. Then by similarly for the next rule, applying k1, k2, k3, k4, you will get the result for y4, that is y of 0.4, which will take the value 74064. This is the required answer, because in the question we need to ask that one, y of 0.4. So this is the required result by applying Kutta fourth order method.